We can determine the enthalpy of a reaction by recognizing that the breaking of bonds is an endothermic process and the formation of bonds is an exothermic process. So by subtracting the average bond energies to form bonds from the average bond energies of the broken bonds, we can obtain the enthalpy of the reaction. And here the superscript represents standard conditions where the reaction occurs under constant atmospheric pressure and room temperature. Now here we say average bond enthalpy because these bonds can exist in different compounds and thereby have different energies. So we take the average. So in this example, we have two hydrogen molecules reacting with an oxygen molecule to form two H2O molecules. So therefore these bonds are going to be broken, which absorbs heat, and these bonds are going to be formed, which release heat. So therefore the enthalpy of the reaction, which we can write also in the following notation, under standard conditions, can be written using the bond energies. So the sum of the bonds broken minus the sum of the formed bonds. So we have two H2O molecules and two OH bonds per molecule. Which gives the following result. So this synthesis reaction is exothermic. And note that all the molecules are in a gas phase. But if this were the liquid phase, for example, then we need to consider the enthalpy of condensation, which is a negative of the enthalpy of vaporization. So therefore this would need to be added to the bond energies of the products. Because condensation is an exothermic process, where heat is released. The combustion of methane is given by the following reaction. Find the enthalpy of the reaction using the bond energies, and given the enthalpy of vaporization of water, because we have a phase change. So first we draw the geometries of the molecules to get a better visualization of the bonds. And now to calculate the enthalpy of the reaction under standard conditions, we have the bond energies of the broken bonds minus the bond energies of the formed bonds. And we also need to subtract the heat of condensation due to the phase change, which is a negative of the enthalpy of vaporization. And given we have two H2O molecules changing phase, And using three significant figures, we obtain the following result. And as expected, combustion is an exothermic reaction.